March 8, 2025. White Paper. AI/ML DNN Network Model, Management and Business Analogies to make them more relatable. About DNN Network. This image represents a deep neural network, DNN, architecture designed for student performance prediction using multiple input features. The architecture consists of 3 hidden layers, each applying a different activation function to process the input data. Structure and functionality. Inputs: the model takes 10 input features, including student data, course content, assessment scores, learning style, study time, previous knowledge, attendance, engagement level, feedback, and external resources. Hidden layers. Hidden layer 1, green nodes, uses the ReLU, rectified linear unit, activation function, which allows only positive values to pass through, simulating performance-based filtering. Hidden layer 2, blue nodes, uses the sigmoid activation function, which maps values between 0 and 1, enabling the model to make risk-based decisions and smooth transitions. Hidden layer 3, pink nodes, uses the softmax activation function, which distributes the final values proportionally, representing a weighted allocation strategy in decision-making. Final output: student performance prediction. The final layer, cyan node, integrates all processed information to make a performance prediction. The combination of ReLU, sigmoid, and softmax ensures that the network captures patterns, nonlinearity, and relative importance from the input data. 1 ReLU layer, rectified linear unit. ReLU, Wx plus b, equals max, 0 Wx plus b, ReLU, Wx plus b, equals \max, 0, Wx plus b, ReLU, Wx plus b, equals max, 0 Wx plus b. Management interpretation. Think of ReLU as a performance evaluation system in an organization. Scenario: a company evaluates employee performance using a performance score, Wx plus b. Policy: if an employee's performance is negative, below a minimum acceptable threshold, the company ignores it, sets it to 0, because negative performance doesn't contribute to growth. Outcome: only positive performance is considered for promotions and rewards. Example in management terms. Suppose a sales team gets bonuses based on their sales performance. If an employee sells above target, positive Wx plus b, they receive a bonus. If an employee underperforms, negative Wx plus b, they get no bonus, 0, but are not penalized beyond that. ReLU in business means focusing on positive results while ignoring underperformance without direct penalties. 2 sigmoid layer. Sigma, Wx plus b, equals 11 plus e, Wx plus b, \sigma, Wx plus b, equals \frac 1 plus e caret dash, Wx plus b, sigma, Wx plus b, equals 1 plus e, Wx plus b, 1. Management interpretation. Think of sigmoid as a decision-making process where an executive evaluates risks before approving a new project. Scenario: a manager must decide whether to approve or reject a business investment. Policy: the decision is not a simple yes/no but rather a probability-based approach. Formula explanation. If the project is highly beneficial, Wx plus b is large, the probability is close to 1, approval is likely. If the project is risky or unproven, Wx plus b is negative, the probability is close to 0, rejection is likely. If the project has moderate benefits, Wx plus b is around 0, the decision is uncertain, 50/50th chance of approval or rejection. Example in management terms. A company is considering launching a new product. The manager evaluates multiple factors: market demand, cost, and potential revenue. The sigmoid function converts all these factors into a probability, 0 to 1, of launching the product. If the probability is above 0.7, the product is launched. If it's below 0.3, the product is dropped. If it's in between, further analysis is required. Sigmoid in business represents risk-based decision-making, where outcomes are not binary but probability-based. 3 softmax layer. Sigma, Z, I equals EZ I sigma jes J backslash sigma, Z, underscore I equals backslash frac E caret Z underscore I backslash sum underscore J E caret Z underscore J sigma, Z, I equals sigma jes Z. Management interpretation. Think of softmax as a budget allocation strategy where a company distributes funds across different departments. Scenario: a company has a fixed budget and must decide how to allocate it among multiple departments. Policy: the budget distribution is proportional to the importance of each department's past performance, Z_I. Formula explanation: each department's performance score, Z_I, is exponentiated to highlight strong performers. The total available budget is distributed based on the proportion of each department's contribution. Example in management terms. A CEO decides how to allocate a marketing budget across different regions. North Region Performance Score equals 5. South Region Performance Score equals 3. East Region Performance Score equals 2. The softmax function converts these scores into budget percentages. North gets 50% of the budget. South gets 30% of the budget. East gets 20% of the budget. Softmax in business ensures fair allocation of resources based on relative importance, rather than absolute values. Final summary in management terms. Mathematical formula, mathematical branch, business analogy, key takeaway. Real U, max, 0, Wx plus B, linear algebra and optimization. Performance review system rewards only positive performance, ignores negative contributions. Sigmoid, 1/1 plus E caret dash, Wx plus B, probability and statistics. Risk-based decision-making, gradual decision-making based on probabilities, not just yes/no. Softmax, E caret Zi/sigma E caret Zj, multivariable calculus and probability. Budget allocation strategy distributes resources based on relative importance. Each of these activation functions helps in decision-making, performance evaluation, and resource allocation, all crucial aspects of business and management. AIML Model, Institutional Performance Overview and Forecast, 2025 to 2027 Growth. This graph presents a performance trend analysis for 5 student batches, Batch A, B, C, D, and E, over time, incorporating both historical data and future projections, 2025 to 2027 growth. It provides a comparative view of batch performance using bar charts and line graphs to show trends. 1. Title and context. The title at the top indicates that this is an AI/ML based model analyzing institutional performance. The name Pradeep K. Suri is mentioned as the author, researcher, and AI/ML architect, suggesting that this analysis is based on AI-driven insights. 2. X-axis, time progression. The x-axis represents the months and years. It starts with individual months from January to June for the current or past period and extends into the years 2025, 2026, and 2027 for forecasted growth. This transition allows for an understanding of past trends and expected future improvements. 3. Y-axis, performance score. The y-axis represents performance scores, ranging from 0 to 100. Higher values indicate better student performance. The goal is to track progress over time and identify patterns in institutional training effectiveness. 4. Data representation. The chart uses 2 layers of visualization to convey insights effectively. A bar chart, batch-wise performance scores. Each batch's historical and future performance is represented by colored bars. Different vibrant colors help distinguish batches easily. Batch A rightward arrow red. Batch B rightward arrow green. Batch C rightward arrow blue. Batch D rightward arrow pink/magenta. Batch E rightward arrow yellow. The bars represent actual performance values at each time point. B-line graph, performance growth trend. Each batch's trend over time is also shown using a line plot with markers. The lines highlight upward or downward trends, making it easier to track performance growth or decline across the years. The lines match the colors of the corresponding bars to maintain clarity. 5 insights from the graph. Upward trends for all batches. All batches show an increasing trend, suggesting continuous improvement in training outcomes. Batch D, magenta, leads in performance. Consistently high scores across all months and projected years. Batch C, blue, shows the most growth. Starts at a low level but shows steady improvement towards 2027. 2025 to 2027 growth projection. The extension beyond June into future years suggests expected improvements due to AI-driven insights and strategic changes. 6. Dark theme and aesthetic choices. The black background, dark theme, enhances contrast, making the vibrant colors stand out. The legend on the right clearly labels both bar and line charts for quick identification. 7. Business and educational impact. For institutions. Helps educators and decision-makers track student progress and modify training strategies. For AI/ML research. Demonstrates how machine learning can forecast educational outcomes. For future planning. The 2025 to 2027 forecasted data supports long-term growth strategies. Conclusion. This chart is an AI-driven educational performance report that, white heavy checkmark, compares batch performance over time. White heavy checkmark forecasts growth trends using AI/ML. White heavy checkmark uses both bar charts and line graphs for clarity. White heavy checkmark highlights potential areas for institutional improvement. This Python program utilizes the Plotly library to visualize institutional performance trends over time using a combined bar and line chart. It defines 5 student batches, A to E, and their respective performance scores across a timeline that includes both historical data, January to June, and future growth projections for 2025 to 2027. The program first initializes the dataset, assigns distinct colors for each batch, and then creates a Plotly figure to represent the data. The bar chart displays actual performance values, while the line chart with markers highlights trends and patterns, making it easier to track performance improvements across time. To enhance clarity and readability, the program applies a dark-themed layout using Plotly_dark and customizes labels, fonts, and graph aesthetics. The bar and line charts are grouped together, bar mode equals group, to allow a side-by-side comparison of batch performances. Each batch has consistent colors across both the bar and line representations. Finally, the figure show command renders the interactive graph, providing a dynamic visualization where users can hover over data points to see exact values. The graph is titled to acknowledge Pradeep K. Suri as the author, researcher, and AI/ML architect, highlighting the AI-driven analytical approach to forecasting institutional performance trends.